So we are going to look at the last part now of today's lesson, and it's just something that used to be, it's kind of like new actually, this topic, the angles between vectors and the coordinate axes. This is something that is new to Maths A level, but that's really because all of the stuff about angles and vectors got moved to further Maths A level. So students who did all the angle stuff in further maths who are in this class, actually all of you used to be able to do this, and now they've got this kind of weird sort of small subtopic about angles between vectors and the axis. So we're going to have a quick look at this diagram that we have here, and it says how could you work out the angle between a vector and the x-axis? So again, I just want to explain a little bit about what this diagram actually means and what this diagram looks like. We have got the x-axis, the y-axis, and the z-axis all running perpendicular to each other. So this is meant to be like a three-dimensional diagram. Some people found it difficult to see that the y-axis is kind of going into the board a bit, and the x-axis is kind of coming out of the board a little bit. And this a vector is not flat. The a vector is kind of in between all three of the axes. So if it was like the corner of a room, if this origin was like the corner of the room, like over here, the a vector is just kind of like coming out at some random kind of angle, okay? It's not flat on the floor, it's not flat on the wall, it's just coming out at some random angle. And we're trying to see what is the angle that this blue a vector makes with the x-axis. How much would it have to rotate until it was sort of flat onto the x-axis that we have there? And you'll see that we've labelled the angle as theta and a little subscript x. A subscript x just meaning like a small x written in the corner, because what we're eventually going to do is find out the angle that it makes with the y-axis and the z-axis. Okay, it's important to note here, we are finding the angle that A is making with not only the x-axis, but the positive x-axis. If we were talking about the angle that this vector A was making with the negative x-axis, it would no longer be an acute angle, it would be an obtuse angle. So if you ever get an obtuse angle, kind of gives you an idea of, with the positive, it gives you an idea of where it's positioned in the three-dimensional space. Okay, the way that we do this is we should see that we have this triangle that looks like this, and it's actually a right-angled triangle where, if I draw it out again separately, there's the right angle that we have, where the end is going as direct to the x-axis. The bit along the bottom here is the x-coordinate of the position vector. What is the hypotenuse of the triangle? Almost A. It's not A, it is the modulus of A. Okay, because a vector can't really be the hypotenuse. We're talking about the length of the hypotenuse. So actually what we're talking about here is the length of the a vector. That's the a vector there, and we're just changing it into a triangle by making its modulus be there instead. And we're interested in finding out this angle here, which is theta subscript x. And all we do for a right angle triangle like this is we apply SOHCAHTOA. Okay, we're going to apply SOHCAHTOA. Which of those three will we be using? We're going to do A over H, so we're going to be using the cosine one, which is where we come up with this that's been written down here, okay? The cosine of theta x is x over modulus A, the adjacent over the hypotenuse. This is the adjacent, this is the hypotenuse, okay? This has a similar formula for the other ones, that the cos of theta y would be y over the modulus A, and the cos of theta z would be z over modulus A. This is the angle it makes with the y-axis, the positive y-axis, the positive z-axis, and things like that. So it's a really simple thing, but it's a little formula that you can remember, or you might be the kind of visual person that looks at a diagram and thinks, oh, if I have that diagram, it will help me remember what the formula actually means. So we're going to just apply this and try and interpret some of the results that we have here, okay? Yes, Sarah? No, you'll never need to use that because you'll always be given the length, and because you're trying to find, sorry, you'll always know the hypotenuse, which will be this part, and because you're always trying to find the hypotenuse, the angle, sorry, between the hypotenuse and an axis, they are always going to be adjacent and hypotenuse, because it's always going to ask for that angle between the axis and the hypotenuse. Okay, good question though. So if we're going to try and find out the angle that this vector makes with each of the positive coordinate axes means it's interested in the angle it's going to make with those ones. We need to just apply this formula, and we're just going to apply it 3 times. So the first thing that we know we need to do is to find out what the modulus of A is, which from the stuff we've done today is just 2 squared plus 3 squared plus 1 squared, which is 9 plus 4 plus 1, which is root 14. So if we want to find out the angle that it makes with the x-axis, we take the x coordinate, which is 2, and we divide it by root 14. And if I want to find out what theta x is equal to, I obviously do the inverse cos of 2 over root 14, which should give us an angle. And you should be in degrees for this, because it's kind of wanting it to interpret it as a degree, so make sure that you're in degrees mode on your calculator. And this should be, as an angle, 57.7 degrees to 2 decimal places, sorry, to 3 significant figures we'll do here, or 1 decimal place. In fact, let's do 1 decimal place. So the y direction, it's kind of hard to imagine it for the, I'm not going to do the y one just because it's really crammed in. The z direction is it's asking what angle does it make with the z-axis, like here, this would be theta z, and theta y is actually kind of like in there, but it's a bit hard to see because it's almost like you're looking at something that looks like this, where you can't really see like what's happening between them, okay? So that's what's theta z and that's theta y. Now this is good that it's making 57.7 degrees because its x coordinate is 2, so it's somewhere over here, which makes sense that it's got an acute angle with it because it's on the positive side of the x bit, so it makes sense that it's got a small angle with the x-axis. If we're now going to do the angle that it makes with the y-axis, so we're going to do cos theta y, really similar process, but the y coordinate is -3, so it will be -3 over root 14. I'm just going to skip that step and go straight to the answer. So -3 over root 14, and if we inverse cos that, we get 143.3 degrees to 1 decimal place. Now interestingly, this type of angle is obtuse. That means that with the y-axis, it's actually kind of so much further, like it's making an angle with the negative. It's kind of gone over the halfway point, and it's closer to the negative side than it is to the positive side. The reason it's closer to the negative side than it is to the positive is because the y coordinate is negative. So it makes sense that it's further towards the negative axis than it is towards the positive axis. You don't need to like know all of that, but it's just trying to interpret what these values mean. And our last one, the cos of theta z, is just the z coordinate -1 over root 14. Now if it's in the negative area of z, we should be expecting what kind of angle here? An obtuse angle. So when we do the inverse cos of -1 over root 14, let's hope that we're getting an obtuse angle. Yep, we do. We get something that is just obtuse, 105.5. If it had a really negative z, it's probably going to be a really much closer to 180 because it's so far underneath here that it's making a really big angle with the positive axis. Kind of hard to visualize, so this is only to push you if you're wanting to really visualize what's happening here. Again, this is just an application of a formula, but we get to use it in 2 different ways on the next page, okay? So we start to do things where we interpret some of these diagrams a little bit now. We start to use some of these skills to try and apply it to some shapes and different problems like that. Can I go on to the next slide in a second? Yeah? You can work these out, even if you've just written the first one down. You can easily do these ones yourself because it's just reapplying numbers to a formula, okay? So we're going to just do 2 of these, and that'll be the end of the lesson. We have got 2 questions. Top one, it says the points A and B have position vectors 4i plus 2j plus 7k and 3i plus 4j minus k relative to a fixed origin O. Okay, great, we've got the position vectors. Find the vector AB and show that triangle OAB is isosceles. Okay, I probably, even though it's just asked me to do something quite simple to start with, I probably want to just draw a little sketch of what is happening here. So I would start off with some kind of sketch. Now, can I draw a nice, accurate sketch for this? Yeah. No, because it's 3 dimensions. I've got no clue what this is going to look like. So all I'm really going to do is I'm just going to say, well, here's O, here's A, here's B. I'm just going to draw this in case it helps me visualize the things that are happening here. And they've told us that the position vector of A, well, that's how you get from the origin to A. They've told us that this is 4, 2, 7. And they've told us that the position vector of B is 3, 4, minus 1. Just to add some things to a diagram so it stops being random letters and it starts being something we can visualize. AB is found by doing B minus A. Good. We can now just start memorizing that, but we can obviously see that it is minus A plus B. B minus A. So we've got 3, 4, minus 1, minus 4, 2, 7, minus 1, 2, minus 8. So that's what AB is there. Remind me of the properties of an isosceles triangle. The 2 angles are the same, but that's going to be harder to find angles with this. The other thing that we know about isosceles is that 2 lengths are the same. Okay, which of these 2 lengths are the same? Do we know that?
Yes.
Pardon? We've got to do all of them because we don't know which 2 are the ones that are going to be the same. The other reason we need to do all of them is because, well, what is the reason we need to do all of them just in case? We don't need to find the angles. In case it's not, if you only do 2, all 3 of them could be the same, and then actually it's not isosceles, it's actually equilateral. But they've told us it's isosceles. So what we're going to do is we will find out the length OA, so we'll Pythagorize this one. Pythagorize is obviously not a real word. Please don't use that when you go to university and say, oh, my maths teacher said it was a real word. So you've got this one, which is 16 plus 4 plus 49, so that's root 69. OB is the square root of 3 squared plus 4 squared plus 1 squared. Well, that's obviously not that. How much? 26. And we're also going to find out what AB is. We've already got this, so we can actually just Pythagorize it. We've got 1 squared plus 2 squared plus 8 squared, which is root 69. So we can say OA equals AB. So triangle OAB is isosceles. Okay? If you wanted to find the area, okay, because there's going to be a question about this in your homework. Okay, I've got a triangle that looks like this. We've just said that OA is root 69, OB is root 26, and OAB is root 69. If you wanted to find the area of this triangle, you could do this back in GCSE. What things would you need to do to find the area of this triangle? But you don't know the angle. We could split it in half, but I want to keep this as general because it's going to help you for your homework. We're going to do it even without that. You could do this from GCSE. You're going to do the cosine rule to find one of the angles. Cosine to find one angle. So maybe you want to find out this one here, and you do the cosine rule to find that out. Then you're going to do a half AB sine C to find the area. So technically you could have done that from GCSE. If you wanted to find the area of the triangle, you can just find the lengths, then do the cosine rule, then do a half AB sine C, because there's going to be a question about that in your homework, and I don't want you to get it wrong. Okay, last one that we're going to do here. Actually, I'll give you a little second to write that down, otherwise I know I rush a little bit, I know I go too fast. But now you can just watch it again in your own time. So we should cram the lessons down into an hour, and I should be like, right, here are all the videos, off you go. if you've written that down, just start reading through the next question and think about what the strategy might be for this, or even just get started.
For this one,
Is finding the area relevant to that question?
No, I was just saying, that's why I've done that in a separate colour, like if this is like an if you wanted. Because I know that there are many exam questions where they just give you this kind of information and they say find the area. And it means basically go back to year 12 and do cosine rule and half AB sine C. It's pretty long, but... And Hassan, there's also a question like this in the homework that you're going to do, okay? Okay, I think so that we make sure we finish before the end of session 1, so we can go to break on time. We're going to do the angle that this vector A makes with the x-axis. They should say the positive x-axis, but it's okay, we'll be all right with it. By similarly considering the angle that B makes with the x-axis, determine the area of OAB, which is going to be a triangle, where OA is the vector A, OB is the vector B. And I've obviously said we're going to need to draw a diagram for this, okay? But I'm not going to draw the diagram until I've worked out the angles, because they might help us to interpret what happens in this one. So let's work out, to begin with, some of the information that we need. To find out the angle that it makes with the axis, what do I need to calculate first? Yeah, I need to do the magnitude of A, which is 2 squared plus 1 squared plus 1 squared, which is root 6, okay? So the angle that it makes with the x-axis, oh, I shouldn't go in that quick. We should still say the cosine of the angle. So the cosine of the angle that it makes would be the x-coordinate over root 6. So the angle that it makes will be the inverse cos of 2 over root 6. Which is, I'm just going to do that to a couple of decimal places, 35.26 degrees. We're going to do the same thing for B. We're going to work out the magnitude of B. And B has got 1, 3, 2. So that's 1 squared plus 3 squared plus 2 squared. So that's 1 plus 9 plus 4 root 14. So then we get the cosine of this one's angle with x. I probably shouldn't really call it theta. Should probably give it a different name just to keep it fair. The cosine of the alpha with x. You wouldn't get punished if you did do that in the exam though. So it's going to be 1 over root 14. So the angle that it makes with the x-axis is 74.50 degrees, and then that one's to 2 decimal places. So the same thing that we did on that previous slide, of just finding the angle between them. But now we want to do something that's a bit different. We want to find out the angles. We're going to draw a sketch of what's happening here. So we have got, I'm just going to draw the axes that I can imagine. I'm just going to draw in fact, why don't we just draw, here's the x-axis that we've got here. And we're now going to draw the other ones. Which one will come first as we start drawing them in this direction? Looking at the angles that they're making with the x-axis, which one will I come across first? The alpha one or the theta one? The theta one, yeah, because it's got a smaller angle, and that corresponds to the vector A. So the vector A, if I maybe take a couple of different colours here, the vector A is making an angle of 35.26 degrees, okay? This is the vector A. But the vector B, if I do this in a different colour, is making an angle of 74.5 degrees. So this angle here, I don't know how I'm going to fit this in. I'm going to do a big angle and I'm going to label it like this, is 74.5 degrees. And I want to find out the area of this triangle. That red triangle that's inside there. So if I draw out that red triangle again, there's a few things that I know. Good. The angle inside here is the orange angle, take away the black angle. It's the difference between them. So that would be your 74.5, take away your 35.26. So the angle is 39.24. What is the length of this side of the triangle? A, which is? Good. The length of this side is root 14. So the area is going to use a half AB sine C. A half AB sine C. I put it in those quotation marks because the A and B might be different. So we get a half times root 6 times root 14 times the sine of, what did we say, 39.24. Put that in our calculators and we get sine of that times root 6 times root 14 divided by 2. And we get 2.90 units squared to 3 significant figures. I should say units squared. Okay. This bit here, where it said find the area, you didn't have to do this. You could have done this process that we talked about up here. You could have found out the length of this side of the triangle. You could have done the cosine rule and found out what this red angle here was. I guarantee it would be 39.24, but it's just, they've asked you to do it in this particular way. So you should think, what information do I have? What do I need to do? And I think the hard thing is, I have shown you this example, they might ask you to do something in a different kind of way. You have to make sure that you pause and you think during an exam or an assessment to think, how would I actually solve this problem, okay? So I'm just going to write down what your questions should be. It's going to be finishing off some of those from the exercise that we started doing in class and just a couple of them about some angles and axes. It's a very, very, very short homework, so it'll give you some time to do some revision. And whatever we do in next vector lesson is obviously important, but it's not going to be coming up in your mock exam, so it's less to feel worried about. Okay, so I'll stop that there.